All right, welcome. I have another exciting video today about Tubescreamer. This is kind of becoming a Screamer series. Last time I did, I breadboarded a clone of TS808 Tubescreamer. You have it somewhere here. You can have a look what I did there. Close and accept. So I go through lots of things. There's lots of diagrams. You go and check it out. For this video, I'll do a side-by-side comparison of the breadboarded version and the actual pedal. I mean, I said I'm gonna do this, and after that I'm gonna talk about what makes the Tubescreamer what it is. From technical perspective, I'm gonna talk about it from technical perspective. There's I'm gonna put a link to a video to a video from somebody who actually knows what they're talking about. So it's Tomo Fujita. He did this. Yeah, without ads. He did a great video how he likes using his Tubescreamer, and he tries out different 4 different Tubescreamers. Definitely check it out. I'll put a link there. When I click on it, ads pop up. So I'll put that into description. And once I finish that, talking about what it makes it Tubescreamer, what the pedal, why Tubescreamer is a Tubescreamer. Finally, I'll modify the breadboarded version to get minimal Tubescreamer version, a version with minimal power count. As always, check out the description for a link to the related blog post and actual and accompanying diagrams there. Okay. So let's get going. First, let's do some sound comparison. I'll actually be using TS9. So I have this TS9DX. It has 3 modes here. I'll just use TS9 classical mode. Now, TS808 and TS9 are not exactly the same, but the difference is minimal. So if you want to check it out, again, I'm going to click on this YouTube video that I have there, but we're going to get some crazy ad. But there is Wampler pedals, Wampler brand goes and talks about busting the myth about TS9 and TS808. Essentially, he's saying that the difference are not in any way significant, and it's more about pots that you use. And I use 25K pot for tone, and instead of 20K pot, because that's what I had, that's more likely to cause difference than using TS808 and TS9. So I'll put links there. So let's hear it. Okay, that was long and slightly tedious. I have full version of this in its full half an hour glory out there. That version is really tedious. Feel free to check it out if you're there, of course. I can't guarantee anything, but you know. Anyway, like, what did we learn? The pedals sound really very similar. I mean, in most of the cases, I got the sound pretty much exactly the same. In some cases, I should have fiddled with the knobs more, but I hope you also feel that the breadboarded version is close enough. For some comparison again of different Tubescreamer versions and how to use them, go to that Tomo Fujita's page. That video. I mean, after seeing the video, I kind of liked my Tubescreamer a bit more because I kind of dig what he has to say there. So, what makes Tubescreamer what it is? I have this schematic here that we've seen in the that post I showed and in my previous video. So this is Tubescreamer. There's some input buffer, output buffer. There's some reference voltages, but the meat is here in this section. So I prepared a bit more detailed diagram here, and I kind of annotated parts that are a bit more important, that shape the sound, if you will. So if I look at things like input buffer, output buffer, for example, let's focus on that. The filters formed by these components are not that not affecting the input that much, and it stands to reason, because if you listen to me trying it out, bypass and actually dry sound were nearly identical. They were identical. I couldn't hear the difference. So if you think about it, that's what you want, and that's what the designers were going for, because the pedal doesn't have true bypass. So stands to reason they wanted to preserve the same sound. So you know, if this part is not important, that leaves us with clipping and tone sections, which should, come. This should come as no surprise because that's really where the tone is shaped. So let's see here real quick what we have. We have I kind of marked in red what really makes a difference, and you can see here there's some input filter here. Doesn't really matter. Doesn't make any difference. This is what is normally kind of quoted as important thing. This filter here. We're talking about cutoff frequency of about 720 hertz, but what that means is that just the amplifier has a really big gain. Minimal gain is about 21 dB. That's like more than 10 times gain. So your guitar signal coming into the op amp is amplified 10 times on the output, just at minimal setting of the gain. Now, obviously, this wouldn't be an overdrive if there wasn't for some clipping, and clipping is symmetrical. And symmetric clipping combined with this gain and this filter is what really is the important shaping part, tone shaping part of this circuit. And there is this low pass filter here that kind of it's formed by this capacitor and this resistor and this overdrive potentiometer, but that really plays into when you have gain nearly at the maximum setting. So your mileage may vary. You might hear some kind of maybe it's brighter without this capacitor, but in reality very little difference. It should make very little difference. But what is really important is these bits here, and that's what this is kind of a clipping section of Tubescreamer. That's what defines the tone to a certain extent. What is important to see is that this is actually just affecting the clipping portion of it. So we'll see next what happens. So pretty much everything over 720 hertz is at full gain, is amplified full gain. Up to that point, there's 20 dB slope there per decade, and it's but again, it's a lot of gain out of the from minimal setting. Once this the sound is clipped, clipping introduces lots of harmonics. There's lots of harmonics at higher frequencies that becomes the sound becomes pretty harsh, and this passive filter here takes out some of that harshness, and this is also very important part of shaping the tone. So that gives that little hump, that we see in frequency response diagram. Now, it's important that this happens after the clipping. So this doesn't mean that higher frequencies are not clipped. They're absolutely clipped in the previous section. This is just after the clipping. This happens after the clipping. Now, this active tone control here, it's actually high pass filter, and here's the frequency, cutoff frequency. This is actually amplifying the signal up to from 0 to 13 dB. What this really means is that filter here and filter, this active filter there, form a band pass filter, and at minimum setting, it really attenuates lots of this filter here is kind of forcing lots of attenuation of the higher frequencies, and then as you increase the tone, it kind of increases the treble, and then at maximum there's also a cutoff at 3.3 kilohertz, because then this filter here attenuates the signal. There is also a filter here, which is really not really significant. When you roll down the level, it affects the cutoff point, but once you get to really low levels, it affects the frequency response, and that's really not important, because at that really low level you wouldn't really even see anything. You couldn't really hear the difference. So if I look at, this is how the tone control works. That's what I was just saying in so many words, and this diagram or this graph shows it, and this is, there is a 3.3 cutoff, so it's 3 dB under the maximum or whatever. This is where I kind of made that point, that where this 13 dB amplification comes in. You see here, that's the active portion of the filter. This is that passive low pass filter. It causes, see, from about 723 was it hertz, there is attenuation, but this is kind of compensated by the filter, and then you get it nearly kind of flat here. It's not really flat, but you know what I'm saying, so that's really it from the things that actually shape the tone. So if I said, we can just get rid of this, yeah, and this, we should get the minimal version, because this doesn't really play into the shaping of the sound. Now, yeah, well, this is true to some extent, by using the bypass, we don't really need input-output, when you use true bypass, we don't really need input-output buffers, but we can just remove them, because input buffer, for instance, makes input impedance high, and by removing it, we might actually affect the sound, we might compromise the sound a bit. To be able to remove this input buffer in particular, we would have to use a different op-amp with higher input gain, input impedance, because this one has a pretty low input impedance compared to something like op-amp with JFET input stage like TL072. Also, what's not immediately clear here, we would be missing a pull-down resistor that helps with the popping sound with true bypass. The Tubescreamer doesn't have popping issue because of the electric circuit does the bypass. So we need to be kind of careful about that. So this is, if we get everything removed. Oh, did this get stretched? Yeah. If I get rid of, if I get rid of input buffer and output buffer, I'm just gonna, you see, I just crossed it out, gone. I still keep this input, but I add this pull down resistor. I need to have it a fairly high value, just so we preserve input impedance high enough. I just replace this BJT op-amp with TL072, and then because I want to preserve that high input impedance, I'm just gonna add, I'm just gonna replace this resistor with higher value. So really what I have here is I got rid of a lot of different components. Input output buffer, Lots of components got rid of, and I just added one resistor, swapped this one, and swapped the op amp. Very minimal change, I would think. And what's best, it should not affect the sound. So let me get to breadboarding it. I'm gonna try that out and see if I'm talking rubbish or not. All right, let's do this. So I'm not gonna remove anything. I'm just gonna go and I'm gonna rewire it. So I don't need to worry about this one. I'm just gonna put that there. So I have this 1K here. So let's see what I'm going to do. I'm going to that was it. That was it. I broke the connection here by moving, you know, this output directly to output, and here the connection goes, you know, this is the input, goes through the capacitor, and should have gone here. Yeah, good, I think. So let me play some. All right, so what I forgot was actually put TL072 and replace my NE there, NE5532. Let me do that. Obviously, it would have been way better if I if I prepared the breadboard the way, you know, specifically for this circuit. But let me, what I did here, I just, meanwhile, I did a bypass here. So what I want to do is I'm gonna plug in this TS9, and I have this bypass, so I can play one and then the other at the same time, and I'm gonna get hopefully to hear that they sound the same. Certainly hope so. Let's see if that's true. I hate this Tubescreamer. Oh, okay. LED is on. That sounded the same, didn't it? Yeah, that sounds pretty much the same to me. Anyway, I hope this was informative, maybe even interesting. I don't know, but I hope you got the takeaway is that this minimal version works as well as the uh, full version of the pedal, and it's also interesting to kind of think of this as, you know, I could probably maybe even scale some of the components if I don't have handy some of the values or some parts that are missing or some things like that. It is still possible to, by preserving the those tone shaping parts, or rather tone shaping elements, if we preserve them, it shouldn't really matter what value components we use. But I'll talk about it in my next video, and maybe you'll find that interesting as well. Until next time.